Hello, today we'll be working on Objective 192. Please bear with me as I'm using my finger instead of a stylus. So this objective is students will be able to, and you wrote this down in class also, simplify, radical, expressions, including variables, exponents, and absolute value. Now, the absolute value we are going to take care of in class because I know there's going to be tons of confusion about it, so I'd rather be there in front of you, so if you have a question, you can ask right there. I'm going to go ahead and flip to the next page. I'm going to be writing bigger than you, so if you need to flip the page, you can. Otherwise, just stay on the page. Now, we all know about perfect squares. Perfect squares. For example, you have the square root of 16. You're able to have a number times the same number to get you there. We know that the possibilities are positive or negative 4. Perfect cubes, that's when you have a number under the radical with a 3 right there. And everyone should know there is a hidden 2 when you do not see a number there at all. So if you take the cubed root, or the third root of 27, you are looking for a number times itself 3 times to get you there. So for 27, you should know that the number is 3. 3 times 3 times 3 will give you positive 27. The next example is if you have the fourth root of, let's say, 256. This is saying what number times itself 4 times. Will get you there. Since this is a positive root, positive 4, we are looking for a positive or negative number that could get us to 456. So our option here is 4 times 4 times 4 times 4, or negative 4 times negative 4 times negative 4 times negative 4. So the answer here would actually be positive or negative 4 also. Okay. Next, I'm going to go over and talk terminology. If I say index or radicand, you know exactly what I'm talking about. So please label the next set of notes terminology. Okay, so I'm going to have you write a radical sign, and you can label that just as so. It is a radical sign. Okay, you'll see some number there, and if you don't, you know that it is 2. This number, or this root, is called the index. So if I ask you what the index is, I'm asking you what root are we taking? And inside of the radical sign, we learned this last chapter, this is called the radicand. That is inside of the radical. Now, at any moment, you can pause. So if you need to write something down, pause the video. Okay. Now, I don't want you to forget what we did last objective. So just as a quick reminder, you should know that all radicals can be written as exponents. I'm going to ask that you review that on your own. So that is, if you have the square root of 16, you know that's the same thing as writing 16 to the 1/2 power. Review that before you go into this video any further. Okay. Now, I'm going to give you some number examples. Again, we did work on this in class, but I do want to give you a set of rules that you have, so when we get back to class, we're not taking a long time reviewing these rules. So for number, let's do numerical examples, no variables. We know the steps are 1, pure prime factorize the radicand. So we're going to prime factorize the radicand. And now you should know that this is what is inside of the parentheses. So prime factorize what's inside. Step 2 is bring any factor. So bring any factor listed as many times as the index to the outside of the radical. And last, we are going to simplify the outside. Again, pause and write this down before you move forward. Next, we're going to do a few examples together. Same as we did in class, but just in case you need a refresher. When you come back, you must know this and you know how to do it well. So, let's take the square root of 343. Now, I knew this was a square root because I do not see a number there, indicating that that is a hidden 2. So the index here is 2. We're going to prime factorize what is on the inside. So I'm going to look for factors of 343. I know that 7 times 49 will get me there. Always keep in mind that your radical is in this expression. Seeing the radical of 7 times the radical of 49 will give you the radical of 343. Next, 7 is prime, so I'm going to circle it. 49 is not, so I'm going to continue to break it down. 7 times 7 will give me 49, and now I have broken it down to all primes. I've pure prime factorized. Now this is saying I'm looking for 2 pairs, so I'm saying 7 times 7 will give me 49, so that is a perfect square. So when I rewrite this, I have 7 times 7 times 7. Here, the index states that I need 2, so I have 2 right there. And I'm going to pull that number out. This right here, I don't have another 7 to go with it, so I'm going to leave that under the radical, and that is my final answer. Okay. Another example, let's take the square root of 27. Now, I should look at this and say, even though 27 is not a perfect square, I can simplify it because it's composed of factors that are perfect squares. So now I'm breaking this down. I'm going to do it this way now. I know that 27 and 1, it won't get me anywhere. So I'll do 9 and 3. That is prime. 9, however, can be broken down further. So I'm going to do the square root of 3 times the square root of 3, and now I have 2 more prime factors. When I rewrite this, just so you get a nice image, we have 3 times 3 times 3 will give us 27. Since again the index is 2, I'm looking for pairs. So I have 3 times 3, that's 9. That means I can pull out 3 to the outside. This last 3 does not have a partner, so this 3 is going to stay under the radical, and that is our most simplified answer. Okay. Now, I'm going to go through quite a few examples just so you have something to work with when you're doing your work on your own. Okay. So, example 3, we're going to take the square root of 256. Okay. Now, when I look at this, I know that this is a perfect square. So if you have memorized your perfect squares and you know majority of them, or at least leading up to, this will be very easy for you. And if you don't, you can still break it down. So I'm going to tell you right now, 16 times 16 will get you 256. But if you didn't know that already, let's break it down on the side here. 256. I know that 4 times 64 will get me there. I can break down this 4 to 2 times 2. Both are prime. I can get here by 8 times 8. Now, you can keep going or you can stop here. If you know that you have 8 times 8 and you have 2 times 4, you have potentially 2 perfect squares, right? At least you know 64 is a perfect square and 4 is a perfect square. So what I would do at this point is I would just pull this out right away. I would say 2, let me show all the work here, 2 times 2 times 8 times 8. Here we have a perfect square. Here we have a perfect square. So I would have 4 times 64. And that's simply saying square root of 4 is 2. Square root of 64 is 8. So our final answer is 16. Now, a different example. Let's say we have the cubed root of a number and the cubed root of 128. I know this is a cubed root because there is a 3 right there. So now I'm looking for not pairs of 2, I'm looking for 3s, right? Saying what number times itself 3 times will give me a certain perfect cube. So I'm going to break this 128 down. Now I know that this is even, so I can always go by 2 if I don't see anything else. 2 times 64 will get me there. I'm going to circle the 2 because that is prime. 64 can be broken down to 8 times 8. These are not prime, so I need to keep going. Also, we are not looking for a perfect square. So if you thought, oh, 8 times 8, I'm going to bring the 8 out, that's not correct because, again, this is a perfect cube. So we're looking for a number repeated 3 times. Breaking the 8 down, we have 2 times 4. Breaking the 4 down, we have 2 times 2. For this 8, we have 2 times 4 again, and we break this final 4 down into 2 2's. Now, I'm going to rewrite this. I don't expect you to do this every single time, but please put your pen or pencil down and just look at how I'm doing this. We have the radical, and we broke the 128 down to all primes. So we have this 2, and this 2. So I'm going to write 2 times 2 times 2. That's a cubed root. Now I have another set. I have 2 times 2 times 2. So I'm going to write 2 times 2 times 2 under my radical. And now I have this last